All right. So up first, we have what is the kinetic energy of an object with a mass of 10 kilograms traveling at a speed of 10 meters per second? So remember the formula is 1/2 the mass times velocity squared. So it would be 1/2 the mass, which would make this 5, and then this squared would be 100. So you'd be doing 5 times 100 for your answer. So this one's a little different because they want you to figure out the gravitation energy at 10 meters and then at 5 meters and then subtract the two. All right, so the formula for potential energy is mass times gravity times your height. Gravity is 9.8 meters per second. That's how much gravity is on Earth. So G for gravity will always be 9.8. So your equation for this one should be 50 times 9.8 times 10. Subtract that from 50 times 9.8 times 5. And then that will be your answer. All right. What is the kinetic energy of a toy, 2-kilogram toy moving at 5 meters per second? So again, 1/2 the mass times velocity squared. Square your 5. So 5 squared times 1. Now here, 5 kilogram is lifted 10 meters off the ground. So it says increase approximately. So this might give you an answer that you need to round. So 5 times 9.8 times 10 will give you your answer. All right, so today I want you to have these notes open. It should look like this. It should say work, energy, and power at the top. I'm going to go ahead and change the color so it's easier to see. And then your Nearpod that you're on should show you a picture. It's asking which person is doing more work. So we're going to talk about work, energy, and power today. All right, so which person is doing more work? So let's look at our answers. All right, the majority of people said person B. All right, but the correct answer is neither. Neither of them are doing more work. Now, why people thought B was correct is because she's moving faster up the stairs. We're going to find out that the speed at which you do the work does not mean you do more work. All right. You can think about it like if you and your friend both had to move 5 boxes from one room into another. If you moved your 5 boxes into the other room in 1 minute and your other friend took 10 minutes, all right, you did the same amount of work. The time didn't matter. You both did the same amount of work. All right, so first off, before we can even do work, we need to talk about energy. Energy is the ability to do work. So energy is the ability to work. We can think about it like the currency that work functions off of, like currency like money. Like you have money, if you need to go buy something, that's the currency you use to do work. Energy has to be input into a system in order for work to happen. Work doesn't happen just out of nowhere without any energy being used. So work needs energy to function. So energy is the currency at which you do work, or it's the ability to do work. Would you type in your notes? All right. Next up, work. So Work is a term you use probably every day. You have to go to work, you have work to do, you have school work, um, this things work or don't work, in your house. So work is defined as the net force acting on a body. Net force is like saying the total force, the overall force. Um, Now I know this is a stretch, but way back when, in I think 8th grade, you guys talked about net forces. If you had two forces pulling on an object, the leftover force was the net force. So it's the leftover force or net force acting on a body and the distance it moved. All right, so the distance has to do with work. If you stand there and you try to lift up your bed, or you lean there and you push on your bedroom wall or your kitchen refrigerator, and it doesn't move, you're not doing work because nothing is moving any distance. So in order for work to happen, distance has to change. So in order for work to happen, it has to have some distance involved. The unit for work is joules, like we did yesterday with energy. So what this all means down here is 1 Newton per meter, or 1 kilogram meter squared over second squared. So that should be going in your notes. All right. So as you probably guessed, we can calculate work and we can calculate how to find it, which will be coming up next. Oh, I'm sorry. You're supposed to put this work, force, business in your notes. So force times distance equals work. Unit work is joules. All right, so in this picture, it's kind of it's a little bit hard to tell, so I'm going to describe it to you. So you got the guy on the left in picture A. He's pushing on a wall. It's not moving. So you can say he might be trying to do work, but no work is happening because the wall is not moving. Now in picture B, that guy's pushing on that the first box, and it's supposed to symbolize it moving to the next box, kind of like one to the next. If that box moves, he's doing work because it's force applied over distance is work. So the only component that the applied force in the direction of the motion so we're talking about the lawnmower here. So there's forces acting on it all, and what this is saying that the horizontal force is the only force we're talking about, because you have an angled force that's pushing on the lawnmower, and you also have gravity force pulling it down to the earth so it's not floating up in the air. So what this is saying is the only component of applied force is the direction of the motion of the lawnmower. So that's where the work is being done. So just because there's forces being applied in other directions, it's the distance that it covers is what we're looking at. Give me a second to write that down. Okay. So we're going to do some practice on work. So before we do, I want to make sure that your guys' notes look like mine. So here's what your notes should look like. The red parts are what should be filled in. All right, so we also have a triangle, work, force, distance. You cover up what the question is trying to find, and that will give you the equation you use. So an object is being moved with a force of 15 newtons across a horizontal surface. How much work is done if the object moved 50 meters? Now, how much work? There's your question. So that means you're going to be covering up the W in your triangle. And if you cover up this W, you're going to have F and D on the bottom. And you go side to side, means you multiply. So here you're going to have 15 newtons of force times 50 meters. Put that in the calculator. 50 times 15 equals 750. Joules of work. That's your answer. All right, let's try another one. All right, 650 joules of work is being done to move a desk a horizontal distance of 5 meters. How much force is needed to move the desk? So this one's not the same as the last one. So you're looking for force. When you cover up the F, you have W on top and D on the bottom. So you're going to have W over distance. Work divided by distance. So it said there's 650 joules of work being done. And the distance is 5 meters. So put that in your calculator. And you get 130. So you should get 130 newtons of force would be needed to do this work. All right. This next one you're going to do on your own, okay? All right. So you have a box. How far will the box slide? So you're looking for distance. All right. If 15 joules of work is applied to a 10-kilogram box. So I want you to write this one out on your screen and submit it. Sorry, Zaria, I just saw your message. Come on, guys, draw it in. All right, thank you, Ednet. Come on, guys. You could probably do this math in your head. All right, Balthazar, very good. Check your math, though. Looks like you put it in the calculator backwards. All right, so if you cover up how far in distance, you're going to have your work divided by your force. So that's 15 divided by 10. Oh, wait. That shouldn't say kilogram. That should say newtons. But anyways, that comes out to 1.5. All right. So had the right setup. This is the right answer. I need some more participation out of you guys. There we go. All right, I'm going to say that one for later. This will be your exit ticket. All right, power. All right, so power, oftentimes has a different connotation, different meaning too. Power can mean electricity, or it can mean like someone who has a lot of influence. Power is the rate work is done. So it's work divided by time. How much work is done over time. if you break it down, it'll make sense, because if you think something that's powerful can get work done fast. All right? If you have a powerful truck, it can move a lot of weight quickly. Otherwise, or if you hook up like a little sedan to the same amount of weight, it might be able to move it, but it won't be able to move it as fast. The power is the rate at which work is done, how fast it happens. So you're going in your notes. So calculating the power is work divided by time. Now remember, work is force times distance. And the unit of power is W for watts. All right, so as you can probably guess, we're going to practice. All right, so up here's our triangle. Now this looks different than the other ones because the work divided by time equation is different than the force times distance. So remember, this work up here is force times distance. All right, so if you have 150 newtons of force to push a motorcycle 10 meters in 20 seconds, all right, what is the power? So now we don't have anything that says this many units of work is done. You have your force here, and you have a distance here. So what it's hinting is that you need to calculate work first. So work is equal to force times distance. And we're looking for work divided by time. So this here is the same thing that goes there. All right, so 150 times 10 is 1,500. Divided by the time, which would be 20. Which equals 7.5 watts. So that's something to watch out for when you're calculating power, is that you might need to calculate the work first. So if it gives you 3 numbers to deal with, make sure you're paying attention, because some problems might just say this much work was done in this amount of time, so you just divide. But if it says force and it gives you a distance, it's hinting to you like, hey, figure out the work first, then divide it. So make sure you're paying attention to that. All right, so you have an 80-kilogram man runs up a flight of stairs in 10 seconds. What is the output? So I want you guys to give this one a try. I think this one's a typo. You know what? Hold on. They should say 80 newtons of force. A man runs up the stairs with 80 newtons of force. So 80 newtons of force. So then that's times 5. Then you divide that by the time. All right, good job, Angelo. Balthazar, good job. You got it right. All right, so here's what it should look like. All right. Very good. All right. So your exit ticket for today is going to be this one. So go ahead, and what you're going to do is you're going to fill this in. So remember that let's see, so I can draw this triangle up here. Oops. All right, this triangle should be work up top, force, and distance. So if you're trying to find the work, cover up the work up here. That will give you 150 times 25. That's 3,750. If you're trying to find the force, you're going to be doing work divided by distance. So you would divide this here. Little hint. You're trying to find distance, you'd be dividing the work divided by the force to go in these two boxes. All right. This is your exit ticket. Make sure you do it and submit it. Your notes should be complete at this point. They were short today. Your notes should look like this. So finish up this exit ticket and submit it. Once you submit it, you're good to go. So make sure you submit the exit ticket and your notes today on Schoology. So your notes should be submitted on Schoology when you're done. If you have any questions, put them in the chat, or you can ask them out loud.